Okay, back again, same system. This time we're going to use Cramer's rule to find x's and y's. Cramer's rule it uses the determinants in the system. It's sort of interesting the way you can start off. You simply write down x is equal to and y is equal to. These are going to be a couple of determinants here. Okay, so we'll find a 2 by 2, a 2 by 2, we'll divide them, that's the x answer. And the same thing with the y, we divide a determinant by determinant, and that's the y answer. And 2 by 2s are pretty quick and easy to do. Okay, so what are these determinants? First of all, start with the denominator. The denominator is going to be the determinant created by the coefficients, 3, 1, 2, and negative 1. And remember, we needed that when we did the inverse. We did this before, this was what, negative 5. So we already know that answer. So you can write negative 5 on the bottom. Negative 5 on the bottom. Now, this is the way I think is probably the easiest way for students to figure out the top determinant. Start exactly the same way. 3, 2, 1, negative 1. 3, 2, 1, negative 1. And obviously that's wrong, right? Because we know the bottom is negative 5. If this were negative 5, then y would be, everything would be 1 all the time. Well, that's not the right answer. So how do you modify this top guy? If you're looking for x, you erase the x numbers. Now remember, the 3 and the 2 came from the x's. If you're looking for the y's, you erase the y numbers. So the 1 and the negative 1 came from over here from the y's. So now the question is, well, what fills those two slots? So I gotta have another pair of numbers somewhere. Well, where might they be? Well, the only other numbers in the system that we haven't used are the 1 and the 8. And those are the numbers that fit there. 1, 8, 1, 8. So it's pretty easy to set up the little 2 by 2 determinants for Cramer's rule. And let's go ahead and work this out. So remember, multiply the main diagonal, that's negative 1. Multiply this way, that's a positive 8. And we subtract. So negative 1 minus 8 is negative 9. Okay, so negative 9 divided by negative 5 is 9/5. That was our x value. And over here, we have 24 going this way and 2 going this way. Remember, you have to subtract. 24 minus 2 is 22. And sure enough, negative 22/5. So we can solve this system using Cramer's rule. We can also solve it using inverse matrices. I'll comment on both of these. If the determinant here happened to be 0, if this denominator was 0, right, then obviously there's no solution, right? You can't find a value with the 0 denominator. Graphically, what that would mean is these two lines would be parallel and they would never intersect, right? No intersection, no solution. It's an inconsistent system. So you have to check that up front to make sure that there is a solution. Just check the determinant of the coefficients, and if it's not 0, then you're good to go. If it is 0, you have to do something else, right? Because there would be no way to come up with the answer using matrices or determinants. Okay.